welcome to JFix. In this video we're looking at this Acer Nitro 5, trying to get it working. This is part 2. I've already done a video that was an hour long. We're trying to just diagnose what this issue is, so please make sure you watch that one first. If you're watching this video, I'll link it in the description, then it'll make more sense what we're doing on this. But let's take it to the bench and I'll recap what we've done so far and yeah, what else we can try. So since the last video, I've actually got the motherboard out of the laptop. I've taken it out to do some further inspection on it. So let's just recap what we've done so far. So this is the Acer Nitro 5. Model numbers there, the GH53G LA L191P revision 1A. So this laptop, I was pressing the power button and it was registering that I'd pressed the power button. It was staying on for like 2 or 3 seconds and then just switching back off. Coming with the power supply and plugging it in, it wasn't. It was drawing current, which was charging the battery. Disconnected the battery and it's basically drawing no current at all. Looking around, didn't seem to be any obvious short circuit on this laptop. So I started checking the power rails. The 19-volt power rail seems to be fine and present. That's always on. Then we checked the 3.3 power rail, which is always on. That one was present, and also the 5-volt power rail was present. So then we moved on to checking the switch to make sure it was registering properly and not getting stuck on, for example. So we checked the signal for the switch, and when we pressed the switch, it was taking the 3.3 to ground and then releasing it when you release the button. So that all works properly. And also we did check that the 3.3 power supply that comes on after the power switch is enabled did indeed come on, and then it switched off when the laptop switched off. So it's still in the stage of kind of diagnosing this. At that point, obviously it starts communicating with the PCH and the BIOS, so we removed the BIOS chip and we programmed it with a BIOS that came off the bad caps that I found for this board, which is supposedly a working BIOS, but that made no difference at all. So yeah, that's the recap of what we've done so far, and let's have a look now, see what we can try next. So just before we start, since the last video I've purchased this from AliExpress, which is a right angle version of the yellow plug adapter. As if you did watch the other video, you'd have noticed I wasn't getting any continuity through the adapter that I had. So I've purchased this one, and I had to use another adapter, which it wasn't quite secure in here, so I wasn't convinced I was getting the best connection. But this one fits in nice and secure in there, so I can get an accurate view now on the power supply of what current this board is using. As I say, it's out of there, nothing's connected. So what I need to do is power on this board. It was pin 1 on that keyboard connector. I've also made up a little probe here to do that. So what I can do is I can just connect that to a ground somewhere, and then I'll be able to use the probe on here just to take that 3.3 on the keyboard, connect to pin 1 to ground, and that should start up the laptop. So that's what I'm going to do now. Let's power up the power supply, program that, and then see what it's doing. So my power supply is on. I'm set to 19 volts at 3.2 amps. I'm going to connect up the laptop. Let's plug that in, and we'll turn the output on. We're drawing 20 milliamps. It's fluctuating a little bit, 4 milliamps, so it's jumping between about 4 and 20 milliamps currently. Let's try and power on the board and see what happens. See if I can get everything in shot. So let's find a ground again for this. And we'll try and short out pin 1 of this keyboard connector. Right, that should be on. Yeah, the power supply 80 milliamps. 85. Right, and it's dropped down to 18. And then we're back to the start. 2 milliamps. Yeah, so it's powered itself off again. Let's just do that one more time. Go. Yeah, up to 80 milliamps. We have got an LED that came on there to indicate the power had switched on. Yeah, it's back to the start again. You can see from the, let me show you the LED. Start it up again. LED's on. And it's gone off again. So it's doing exactly the same thing with the board on its own, with everything else disconnected. Before I go any further, I think what I would like to do is, because in the last video I took this BIOS chip off and programmed that with a BIOS just to test it, and it didn't help. I've introduced another unknown now by putting that unknown BIOS that I found on the bad caps onto there, and I'm not sure, after doing a bit of research, if you can just drop another BIOS onto there, because this is an Intel CPU. The BIOS has different regions, like an ME region, so it may have to be that you have a custom BIOS file based on the one that you ripped off here. So I'm going to take this BIOS chip off the board, reprogram it. I'll do that off camera because I've already done it on the last video, shown that. So I'm going to just go back to my original BIOS, so I'm not introducing another unknown while I'm trying to fault this. And then next stage is, I've got this thermal camera that I've not used yet. Well, I've given it a go just to see if it works. I've got it set up on the phone, but this is a nice bit of kit. Infrared P2 Pro. So it's got the camera like that, and this is a macro lens to zoom in closer. So what I'm thinking to do is power on the board, and then, because it's drawing 80 milliamps temporarily, as we've seen, 85, just see if anything untoward is heating up on the board. Might give me any idea of what's causing the issue. So program the BIOS now, and then I'll come back to with the thermal camera as the board is loading. Right, so I've got the thermal camera loaded. I am going to use this probe connected to a ground to short out the keyboard connector. So we'll do that now. Right, now the laptop shut. Yeah, there we go. PCH is getting warm. It's glowing. Oh, got something here as well. And now it's cooled down. Okay, let's try that again. Short out the keyboard connector. Yeah, laptop's starting up. I can see that's the PCH here. And there's something else getting warm around here. That looks like a quite even heat, so I'm suspecting that's normal. And this glowed up for a second. What I'll do now is I'll try fitting the macro lens, seeing if I can get. Looks like it's still flashing actually. Something's pulsing. I'll get the macro lens on and see if we can get in for a bit of closer detail now. So under that thermal camera, it was this PCH that was heating up, which looks normal, and it was one of these chips down here, and I just did it again off camera, and it looks like it's this one that's heating up. And if I zoom in on that one, I mean, this thing is tiny compared to your finger, but this power supply here is the 3-volt power supply, the 301. This one here is the 5-volt power supply, 501, and then you've got a 1801, so 1.8 volt power supply. So it's this chip here that's heating up. So I'm going to use the macro lens, I think, now, and just take a closer look at what this one's doing. Let me just zoom in on that a little bit more. Get that in focus. So So it's a BA9 DQK. So yeah, let's have a look at this chip under the macro lens. Right, I've got the macro lens attached now, and looking at that 3-volt power supply, you can see, even in the laptop with standby, it's just pulsing on and off, but in one single corner, not even heat over that chip. So let's keep the thermal camera in place, and I'll try and switch on the laptop, and then let's see what behaviour it does. There we go, laptop's on. Let's watch what happens. The light goes out. It's glowing up in one corner and then goes back to pulsing. So it almost looks like it's trying to do something, but it doesn't quite get back there. It's going back pulsing again. Try that one more time. Laptop's on. The pulsing has stopped. Waiting. There we go. It glows up really hot in one corner, and then it's going back to pulsing again. So the question is now, is this chip heating up because it's faulty, or could it be that one of the outputs is maybe shorted on this power supply? That's kind of more of a symptom of it heating up, or a fault elsewhere, or is it the chip itself that's faulty? So I'm going to go back to the schematic, I think, and just see if I can test the output on there with a multimeter to ground, and just check the what resistance on there and see if it looks like there might be a short circuit on this chip. Okay, so I'm on the schematic now, and I've searched for the PU301 and found this LDO IC. So it looks like on here, have a look at it. The input comes in at the top here across 4 pins, pin 2, 3, 4, 5. That's our 19-volt input. And outputs, we've got on pin 9, the plus 3-volt always present. And we have confirmed that we've getting a 3.3. So that seems to be fine, not shorted. And then we've got this second output, LDO output on pin 17, which is the plus 3-volt present on here. So it could be that leg there is shorted when it tries to enable this one. The chip's heating up, could be a symptom of that. So I think it makes sense if I can check pin 17 on here and see if that output is shorted or not. So if I go over back to the board view here, here's our 301 chip, and we've got the pins down here. Pin 17 is on this side, and it goes through this ceramic capacitor here. That top side's ground, and the bottom side should be the plus 3-volt here. So if I could check it there and make sure that's not shorted, and if that's okay, then I think we'll go ahead, order up this chip and try changing that out. Okay, so we can see the dot indicator there is pin 1, which is there, and then going around 2, 3, 4, 5 was the 19-volt input, and you can see they're all on this same big track coming in here through these capacitors. And so if we went round to pin 17, it's this one here, and you can see the track going here up to this capacitor. So that's the output. Let's check that now with the multimeter and see if that's shorted or not. Okay, so I've got black probe on ground. Let's just check I've got a good ground. Yep. So let's see if I can probe in on there, on that little capacitor. And we're showing kilo ohms on there and rising. So it looks like it's charging up that capacitor as a measure. And the other side of that should be ground. Yeah, 0 ohms on that side of the capacitor. And there doesn't appear to be any short on that output. So let's have a look and see if I can order up this chip and try swapping that out. Right, I managed to get these from AliExpress. It took a few weeks to arrive, but they seem to be the right one. I've actually ordered 5 of them because I've got no spares at the moment, so as something goes faulty I'll try and order, you know, multiples of them, because that could be a common point of failure, and then I won't have to order them next time I get the same fault again. And as these spares get low, I can just order and replenish them if I start using these up. But it looks like it's compatible with a lot of different ones, and hopefully it's the right one, and hopefully it works. So let's get this other one changed over and see what happens now. So I think I'm going to prepare this chip first before I actually solder it. It's a BAB-ALG. So the one that's on the board has got a different 3 letters at the end, but it's a BAB, and apparently it looks like they're all compatible. But I'm quite surprised just how small this chip is. If I zoom out, compared to a fingernail, it's tiny, and the pins of it are underneath. I can flip it over, so I'm not going to be able to tell if these are soldered correctly once it's on the board, because you can't see them being underneath. So just to make sure I get the best connection, I think I'm going to just put a bit of flux on this now, and then add a little bit of solder to these pins. Hopefully that'll help it to solder to the board correctly. Right, I'll try and hold it with a tweezer, I think. Come with a bit of flux. Okay, right, let's get some solder. I'm going to use the small 115 iron. Don't think I need too much. Okay, that's done it nicely, so hopefully that'll settle on the board now. Right, let's use the hot air to take the existing one off the motherboard now. Okay, I'm coming with the hot air. I'm at 450 and 150 airflow. And the old chip is out. Pin 1, bottom left hand corner. Right, that's flown off. This is definitely not as easy as it looks. I've managed to find that chip that flew off. Now I'm going to apply a bit of flux here, see if that will help it stick down a little bit. And I think I'll try and hold it with the tweezers this time as it sets down in place. Then hopefully when the solder warms up I can let go. Right, I think that's about right. Get the hot air on it again. Right, let him go. Oh. nudge it back in. Oh, bounced in place there. Got a little nudge, yeah. It's moving. I think that's soldered in place. Right, let me cool that down. But it seemed to bounce in place, and as I was nudging it, it was going back. Hopefully I haven't knocked off any other components while I'm working that. I think I'm just going to do a visual inspection now. Let's wait for the hot air to cool down, because it's quite noisy. I actually think I'm okay. Seems to have soldered in place. Let me just give it a clean up. I don't think I've knocked any other components. Okay, let me get this ready and we'll try and test it now. Okay, board's had a chance to cool now, so let's connect up the power supply. I'm going to switch the output on. So we're 19 volts, 20 milliamps, 4. Okay, let's come and switch the board on. Take the ground I've got connected there, pin 1, so the board should be starting. Okay, we've got a stable 85. Okay, that's definitely changed. That stayed a lot longer for 80 and that's dropped down. But it might be because I've got no heatsink on here. I think that's definitely a change in behaviour. Now I've changed that. That might have resolved the issue. Oh, I haven't got the memory sticks in as well. Let me stick the memory stick in and stick a heatsink on. Let's try that again. Oh, this is exciting. It's promising. Right, I've got a slot in there. Let's stick a couple of heat sinks on. Right. Okay. Let's try and start the board again. Board starting. Show you the power supply. Right. 800 milliamps. And that's staying on. Oh, it's gone to 18.2. Okay. Let's just keep an eye on that. Ooh. We'll leave that going for a while. Might be doing a restart because of the BIOS. No, okay. Right, it's actually a few weeks later. I can't remember exactly where I got to. But I changed this chip and basically I thought it might have fixed the issue, but it's still exactly the same behaviour. So no change. And I don't really know where to go from here. I started going down, checking the signals from the chip, some of the signals that were required for the power on, and some of these signals are indeed missing. However, it's very difficult to trace these signals because, for example, when you look at the board view, the signals come up on like positions like this, which are not occupied. Where they are on the board view, but when you look at the actual board, the positions aren't occupied. But the missing signals from the PCH don't seem to be reaching the EC chip. So at this point, because I'm new to this, I'm kind of struggling with this board now. Don't really know how I can take it further at this point, because is it the PCH not giving out the signal because the PCH is faulty, or is it perhaps something like the power supply is not releasing a power good signal that's enabling something else, enabling another signal to come on. I was hoping this laptop would be more just a simple hardware failure, but it's just very difficult for me to diagnose. I think if I kept going with it, I might be able to get to the bottom of it, but it's used so much time, and I want to release some more videos on my channel, and it's taking up, yeah, I don't want to spend all the time on this board, so I think I'm going to have to at this point call it, whether or not I come back to this when I've got a bit more experience and might be able to diagnose it. So yeah, I'd be happy if I could actually prove something was wrong, even if I couldn't repair this board. If I could say, yeah, MOSFET's shorted, GPU's faulty, or the PCH has got a short on it, it's faulty, you know, and it's just the fact that I can't really diagnose it. It's very frustrating, but I'm sure as much as me, your viewers on this would actually like to know exactly what's wrong with this board. So maybe I will send it somewhere, see if someone else can have a go repairing it, another YouTuber, probably Soren. I'll see if I can ask him if he'll take a look at this board perhaps, and then I can get some feedback on what the actual issue was. But for now, I think I'm going to put it back together, and I'm going to call it quits on this video. As I say, I've got a lot more videos that I want to do and other items waiting to have a go at. So yeah, unfortunately, I'm going to call this a no fix on this point, but yeah, it might still be fixable. Okay, thanks for watching. Sorry it's not the outcome probably wanted, but maybe we'll get an update on this in the future.